Okay, now what I've done is I've taken our rotor off of this side. I've placed it directly on the drive shaft of our induction motor. I've increased the number of armatures, the number of coils on our generator, to 4. And what I'm going to do in this test is I'm going to show that 4 coils will accelerate the system faster than a single coil. What I'm also going to show in this part of the demonstration is that when the coils are shorted out, when current is flowing in the coils, the system accelerates. When the coils are disconnected and the motor is left to run the system completely on its own, it decelerates. When the coils are engaged, shorted out, the system accelerates because the back EMF is causing the rotor magnetic field to strengthen and the speed increases. Now, we recently had a report produced by Connectrix, research facility formerly of Ontario Hydro, and their report concluded that the motor capacitor in conjunction with the starting coil was the main factor that contributes to acceleration. Now I'm going to prove that that is impossible because the system does not accelerate until I short out the coils, and when the coils are disconnected, the system decelerates, and I'm going to show that next. Okay, what we have here again is our magnetic rotor that is directly magnetically coupled to the rotor drive shaft of the induction motor. We have our 4 coils, and then we come over to our meter board. We have our motor current again. We have the output voltage of coil number 1, coil number 2, coil number 3, coil number 4, and again our tachometer meter is here. What I'll be doing during the test is I will be shorting out each coil, inducing the maximum amount of back EMF into the air gap, and the system will accelerate. Now, what I will be doing in this test also is the system will accelerate, and then I want to demonstrate beyond a shadow of a doubt that the motor is not able to accelerate the system on its own, and I will disconnect all the coils, and the speed of the system will drop. And when I disconnect all of the coils, the system will be operating under no load conditions, and the motor will be driving the system solely on its own. And you will notice that because there's no back EMF in the air gap, no generator back EMF increasing the motor's rotor magnetic field, the motor doesn't have the capacity to maintain the accelerated speed. Okay, I'm going to start the system now. Our system speed right now is 54, 55 RPM, 56. We're drawing 5.6 amps to our motor. We're producing 52, 51 volts, 74, 43, and 43 volts. Now I'm going to short out the coils. We're at about 60 RPM there. It seems to be fairly steady. Short out all of the coils. And you can notice that each meter here is pretty much on 0 volts. And the tachometer coil is reading 72, 73, 74 RPM. The motor current has dropped to 5.1 amps, and the system is accelerating. up to 96, 97 RPM. Just going to let it accelerate a little bit longer, and then I'm going to disconnect all the coils and keep an eye on the tachometer. Okay, I'm going to disconnect all the coils now. You can see that the coils are disconnected. We're on no load. Voltages 78, 134, 72, 77, and our speed is dropping to 95, 94, 93. Right now the motor is turning the system, and it does not have the capacity to maintain the speed. I'm going to introduce back EMF into the system again, and you can notice that the voltages are all zero. And I've introduced back EMF into the air gap, and the system begins to accelerate once again. Right now the motor current is at 4.55 amps, and the system will continue to accelerate. Essentially, the feedback loop that's happening is the generator back EMF is increasing, the rotor magnetic field is increasing, the speed is increasing, and I'm just going to shut off the coils now and let the motor do the work on its own. And you can see again clearly that the system is decelerating back down to its no load speed. It will continue to decelerate down to approximately 50 RPM. And I'm going to show you. Okay, what we showed in test number 1, we showed a non-magnetically coupled generator that was operating at a motor no-load speed shown here. And then what we did was we introduced resistance into our coil. We shorted out our coil, and we introduced the maximum resistance that we can for our generator. And when we did that, what we saw was the generator RPM slowed until the system completely stopped. Then what we did in test number 2 was we inserted the ferromagnetic material between the induction motor and generator. Essentially, we magnetically coupled the generator to the induction motor. When we shorted out our coil again, instead of slowing down, as Lenz's law states and the law of conservation of energy states, the system accelerated. Now, in a conventional generating system, as the load increases, if you want to maintain the frequency of your generator output, you have to offer more power to your prime mover. In the magnetically coupled system, in test number 2, if you want to maintain a certain frequency in these conditions, you have to reduce the power going to your prime mover. The open circuit test shows infinite resistance. We have maximum voltage, zero current, and no back EMF in our air gap. When we short out our coil, we have 0 to minimum volts being produced, and maximum current and maximum back EMF in the air gap, and maximum results for our test scenario here.